Okay, so let's look at this question here. This is the second part of finding the real cube root of 27. If you have not watched the first one, I encourage you to watch the first one first because it's going to make the second part a whole lot easier to follow. Okay, so when we're asked to find the real cube root of 27, in the previous video we already proved that 3 cubed is 27, and then we proved that negative 3 plus 3i squared at 3 over 2 is cubed is also 27. So all I have left to do is to take this one, cube it, and see if it gives me 27. So if we look down here, I've already started the process. I've rewritten what cubing a number means. So I rewrote the same values 3 times. I'm going to multiply them together. So what happens? Well, again, just like from before, we have well, you can look at it in a number of ways. Let me look at this as a minus b, quantity squared, which is equal to a squared minus 2ab plus b squared. So I'm going to follow the same exact game that I played last time. What does that mean? That means I'm going to square negative 3. It's going to give me 9. What does that also mean? That means in the back I'm going to square 3i squared root 3, which is going to give me 9. I squared again is negative 1 times 3, because the square root of 3 squared is 3. Then we're going to do the middle, which is going to be negative 2. A is 3, negative 3. And B is going to be 3i squared root 3. Be careful here. It's an easy mistake to be had here. Remember, the way I wrote this, I wrote A minus B. So A is negative 3, but B is 3i squared root 3. So because I called B 3i squared root 3, when I put it here, it has to be 3i squared root 3. It doesn't have to work that way. You can work it out differently. So if I had put this as a plus right here, then B would be negative 3i squared root 3, because you could put a plus sign between, say negative 3 plus negative 3i squared root 3. So this is kind of a cool little thing in math. You can always rewrite things according to how you want it to work for you. But I try to pick, I think, what was most intuitive. So hopefully that makes sense. Let me continue. So if I clean this up, I get 9 plus, I got plus from negative and negative. 2 times 3 is 6. 6 times 3 is 18. In the back I get negative 27. So let me clean this up a little bit. 27 in my mind is 3 times 9. And 9 is 1 times 9. So if I have 1 and I take away 3, I have negative 2. Negative 2 times 9 is negative 18. Negative 18 plus 18i squared root 3 all over the denominator, which is just 2 times 2, which is 4. Okay? So I got some space. Let me keep going. Oh, wait, what did I forget to do? Of course, I can reduce. So that's 9, that's 2. All of those are divisible by 2. So now I have negative 9 plus 9i squared root 3 over 2 times, remember we have another one here, so let's write that down, negative 3 minus 3i squared root 3 all over 2. Okay, let's keep going. So we're going to multiply this out. I think I can squeeze it in here. Negative 9 times negative 3 is 27. Negative 9 and negative 3i is going to be plus 27i squared root 3. 9i squared root 3 times negative 3 is negative 27i squared root 3. Notice it's the same effect from last time. And then you have negative 9i squared root 3 times negative 3i squared root 3, which is negative 27. I squared is still negative 1. Square root 3 times square root 3 is 3. So again, 9 times negative 3 is negative 27. I times I is negative 1. square root 3 times square root 3 is 3. Okay, it's all over 4. I'm not going to worry about that right now. Just like from before, the 27i square root 3 and the negative 27i square root 3 cancel out. Just like from before, negative negative becomes a positive, so I am left with 127 plus 27 times 3. And just like from before, that means I have 4 27s. And again, 2 times 2 is still 4, so all of this is over 4. And I get 27. Okay. The next thing I kind of want to explore, and I'll do this in the next video, but I want to kind of look into, is to see if there's some sort of relationship between the cube root, the fact that you have nothing but 3's here. I'm curious if what happens if this is sort of a property that exists such that whatever the number is, if I write it in this format, so in other words, 4 cubed is, or let's do 2 cubed is 8, right? 2 cubed is 8. So had I put all of these as 2's, would that still work out? Is that a certain property that always exists? So I'm going to explore that and see if I can prove whether or not that's true or not. So that should be pretty interesting. So hopefully you stick around and see if we can figure out what that really is. All right, I'll see you all in the next video.